Here we're going to look at work and energy and putting those together. So we're going to first start out with kinetic energy, or we'll use Ke as the symbol, and that's going to be energy of motion. So things will be moving. So the more something's moving, the more kinetic energy it's going to have. Now this is going to be dependent on the mass of the object and the velocity. So the equation for kinetic energy is 1 half times m times v squared. So 1 half mass velocity squared. So if we look at this problem, how would we set this up? So if Ke is equal to 1 half times the mass, so our mass is 3,000, times our v squared, so our velocity is 24.5, and we would square that, and then we would multiply all that together. For our next problem, we have a gas molecule in a room, and it has a speed of 500 meters per second. If its mass is equal to 5 times 10 to the negative 26 kilograms, what's its Ke? So again, Ke is equal to 1 half m. So here we have 5 times 10 to the negative 26. And then v squared, so 500 squared. We're also going to look at what's called the work energy theorem. So the work done on an object is going to be that change in kinetic energy that it would have. So work equals change in Ke. So to solve for that, we're going to go through this, but really the yellow is what you need to have on your equation sheet. So if we know that work equals force times distance, and if we also know that force equals ma, we can substitute the ma in for the force. So we can say that work equals m times a times d, mass times acceleration times displacement. If we also know that to solve for displacement, we can say vf squared equals vi squared plus 2ad. We can substitute that ad in, and then that's going to give us work times mass times all of this. And that's what we've got there. So this is just kind of a proof to get to this. So we're going to have, this is the final kinetic energy minus the initial kinetic energy. So when we say, what's the change in kinetic energy or what's the work, we can use our velocities, just like we've done in previous equations. So we can say work is final Ke minus initial, or we can use what we've got here, depending on what they give us. Potential energy is going to be based on the gravity of the object. So it's going to depend on the object's position, how far away it is from the Earth. So potential energy is mass times gravity times the height. So if we look at this, the guy riding the bike, the more he goes up the hill, the more potential energy he's gaining. And as he goes down, his velocity is going to increase, and so will his kinetic energy. And so if we look at this, if we watch the roller coaster and the change in the blue and green graphs there, when the potential energy goes up, the kinetic energy goes down. And then the opposite, when potential goes down, kinetic goes up. So a lot of the time they're inverse of each other. We can also solve for work based on our potential energy, but this time it's going to be initial potential minus final. So we can use mgh for our initial height and then our final height. So if we look at this problem, what is the PE relative to the ground of a 0.15 kilogram baseball on top of 100-meter tall building? So we're just looking for potential energy, which is mgh. So we said the mass is 0.15, gravity 9.8, and then a height of 100 meters. And so we would multiply those together to get our potential energy. Here we have a 2 kilogram ball hanging at the end of a string that's 1 meter from the length of the ceiling. The height of the room is 3 meters. So let's kind of sketch that out. Let's say this is our ceiling. There's 1 meter for the string. The total height is 3 meters. So the ball is 2 meters from the ground. What is the potential energy of the ball relative to the ceiling? So compared to the ceiling, the potential energy is going to be down 1 meter. So if we do M, which would be 2 for our mass, G 9.8, and then our height was that -1, so our MGH. Then for part B, if we're doing potential energy compared to the floor, mass of 2, G, and then our height, the ball and the floor was 2. A point at the same elevation as the ball. And again, the ball is at an elevation of 2, so it would be the same as we just found relative to the floor. We have a skier with a mass of 60 at the top of a slope. At initial point A, the skier is 10 meters above point B. Choose the 0 level for PE to be B and find the PE of the skier at point A. So if A is 10 meters above B, which is 0, then we'll call A is at 10 meters. So our P would be M, G, and then a height of 10.